Hello, everyone. So we are going to continue with manufactured fibers today, but on Monday, we covered the manufacturing process for manufactured fibers. So this was the process that we use for any manufactured fibers, man-made fibers, synthetic fibers, regenerated fibers. So now that we know how they're produced, we're going to start talking about different types of man-made fibers. So if you guys remember this list of fibers, we have already completed all the natural fibers. We talked about cellulosics, proteins. Now we are getting into manufactured fibers. And when we talk about manufactured fibers, there are basically two main categories. The first one is the regenerated fibers. These are fibers that are regenerated from natural materials, natural raw materials. And then there are the synthetic fibers. So most of the fibers like nylon, polyester, acrylic, monoacrylic, those are synthetic fibers that are completely synthesized. They're usually petroleum byproducts. The regenerated fibers use natural raw materials, but then we have to turn them into fibers. So you go through a manufacturing process. So these are not completely man-made, I should say. They are probably the closest to the natural fibers in some of the properties. And we have regenerated fibers made out of cellulose, and we have regenerated fibers made out of protein. The cellulosic ones are fibers like rayon, lyocell, and acetate or triacetate. So we're going to talk about these fibers and their properties today, and we'll cover these. Protein fibers are not used so much in apparel. We are going to focus more on the cellulosic regenerated fibers. Like I said, these have properties that are closer to the natural fibers than any of the synthetics here. Okay, so these fibers usually use, the cellulosic regenerated fibers use cellulose as their raw material. And rayon, lyocell, acetate, triacetate, bamboo, there's bamboo rayon, there's modal. So there are a couple different kinds. And Aslan is one of the protein based regenerated fibers. So it uses protein instead of cellulose as the raw material. We're going to start talking about rayon. Rayon is kind of a popular regenerated fiber. It was also the first fiber that was regenerated. When it first came out, they marketed it as artificial silk because it was kind of silky and flowy. It had good drape. It's made of 100% cellulose. So it looks a lot like cotton. It has this chemical composition and molecular structure similar to cotton. It doesn't really look like cotton when you make the fabric. It also is similar to linen because it's also cellulosic, but rayon molecular chains are shorter, which means it's a weaker fiber. It's less crystalline, so it is a little bit different from cotton in that sense. So if you guys remember, if it's crystalline, it's stronger. If the molecular chains are shorter, that means it's weaker. So short and less crystalline means these are weaker fibers than cotton or linen. We use wet spinning to produce rayon. We also have a different variation of rayon we call high wet modulus rayon, which is a stronger version of rayon. Rayon actually has a lot of different versions. There are variations of it that are produced in different ways. So there's viscose rayon, there's modal, there's lyocell. So those are all different kinds. You can have them in a flat cross section. This is the longitudinal view of viscose rayon, and you see those lines on its surface. And that's one of the ways that you can tell if a fiber is rayon. If you look at it under the microscope and you see these lines, it's probably rayon. When it's flat, it reflects light better, so it actually has more of a luster to it. You know, if you want to identify rayon, one thing you can look at is under the microscope, you can look at those lines on the surface. But another thing is you can burn it. And if it burns like cotton, if it burns right away, it's going to give you an idea that it may be rayon. It may also be crimped sometimes. Lyocell is also 100% cellulose. And lyocell is a very similar fiber. It's kind of a variation of rayon. But the polymer chains, the molecular chains are a little bit longer, so it's a little bit stronger than rayon in general, and it doesn't collapse on itself as rayon does, so it has more of a rounded cross-section. So this is the lyocell fibers. And I don't know if you've ever seen those lyocell, or it's also called Tencel. Tencel is the registered trademark for lyocell, especially if you see those denim fabrics that are really, really soft denim. Those are usually lyocell. They're made out of lyocell fibers. We use solvent spinning, which is kind of dry spinning. You have to dissolve the raw material in amine oxide to create the solution, and then you push the fibers through the spinneret. Both of these fibers are lustrous fibers. Sometimes we have to add the lustrants to the solution to remove some of that luster. And they have excellent drape. This is one of their biggest properties. If you wear anything viscose, rayon, viscose, modal, those have really nice drape when you wear them. It's very different from cotton. It's not as stiff as cotton. And because of drape, it's usually used in women's apparel. The opacity can be changed. Rayon wrinkles, but wrinkles are easier to iron out. Lyocell has better wrinkle recovery than rayon, so it's a little bit less wrinkly. Regular rayon doesn't have very good dimensional stability. It's a weak fiber, and it's even weaker when it's wet. So laundering it is a problem. Usually dry cleaning is recommended for regular rayon. But lyocell and high wet modulus rayon have a little bit better dimensional stability. They don't shrink as much when they're washed. So lyocell and high wet modulus rayon are a little bit better when it's laundered. Rayon fibers don't really keep their shape very well. So we don't really use them in knits because they're just not good with that. They are hydrophilic fibers, and rayon is especially even more absorbent than cotton because of that large surface area it has, and it's less crystalline, which means it has more amorphous regions, so that absorbs the moisture a lot more. So rayon and lyocell are not like polyester or nylon. They are more comfortable in hot weather because they are cellulosic, they absorb moisture, they are hydrophilic, they don't cause static. So they're actually a lot more comfortable to wear compared to synthetic fibers. Rayon doesn't really stretch. They don't have any static buildup because they're hydrophilic. They don't irritate the skin. I mentioned the weakness, rayon, regular rayon especially is weaker when it's wet. Lyocell and high wet modulus rayon are stronger, and lyocell doesn't really get weaker when it's wet. And high wet modulus rayon is a variation of rayon where they have increased the strength of the rayon by doing some fiber modifications. Rayon has really bad abrasion resistance, especially when it's wet. If you go through a lot of wear, it's going to wear out really easily. Lyocell, especially if you're agitating it a lot or abrading it, it will split and fibrillate. So that's a problem with lyocell. And they do deteriorate if they are exposed to sunlight a lot. If you have anything that's rayon or lyocell, you have to be very careful about washing them. Make sure you follow the care labels. If it says dry cleaning only, it has to be dry cleaned only. And rayon absorbs water very easily. So if you have any water soluble fluids, it will be very difficult to remove that stain. So you have to be careful with rayon. High wet modulus rayon can usually be machine washed. With lyocell, because of the fibrillation, agitation and moisture is not recommended. You can iron them easily though, and when you're storing them, it's exactly like cotton and linen. You have to keep them dry, you have to keep them away from mildew, and if there's any fruit juices, acidic stains on them, you have to wash them and clean them. As you know, if it is washable, you have to clean them, or you have to get it dry cleaned before you store them. Otherwise, the fruit juices and acidic juices will damage the fibers. Silverfish will also damage rayon and lyocell because they are cellulosic, and silverfish likes cellulose. These are different trade names: Modal, Bamberg. Lyocell is usually called Tencel. That's one of the trade name registered trademarks. We use rayon a lot in apparel, furnishings, drapery, upholstery, a lot of disposable products, wipes, medical supplies, bandages, diapers, napkins, tampons. Lyocell is used in business wear, leotards, hosiery, casual wear, upholstery, window treatments, conveyor belts, specialty paper. So I'm going to show you guys a couple interesting uses of rayon and lyocell. If you go to your iTextiles, now this is Tencel or lyocell. Tencel is a registered trademark, as you can see. This is the raw material. Those are wood chips, and wood chips have cellulose. They're cellulosic plant-based materials. So this is your raw material, and then you have to create pulp out of this, and then the pulp is turned into fibers eventually. And you can kind of see the luster here, so it's very different from cotton. And you can see the crimp on the fiber as well. So there's viscose rayon, there's modal, there's cupro rayon, there's high tenacity or high wet modulus rayon. So there are a lot of different kinds of rayon. There's also bamboo rayon, which is made out of bamboo wood chips. Lyocell, again, is kind of a subclass of rayon. And modal is also another one. Now, just to compare them, this is a rayon surface. This is the cross section of rayon. It's not perfectly round. But if you look at modal, for example, it's a little more round. Lyocell is pretty round in cross section. And they're all very lustrous fibers. And let me see, we talked about all of these. I'll show you some examples. This is a cotton and modal blend with 5% spandex. So, you know, if you wear regular 100% cotton shirts, they're not going to have any drape. But if you have anything that has some modal or rayon, I mean, modal, rayon, viscose, these are all different variations of rayon. So it's going to have a little bit better drape when you have some rayon in the fiber. In household and institutional textiles, we use them like table linens, bed linens, towels, bath mats, and we also use them in technical textiles. For example, we use fire retardant rayon for protection against heat, molten metals. Kordenka is another trademark. This is a high tenacity rayon. This is used in tires, car tires, hoses, and then, you know, some super absorbent cellulose based, you know, versions of it are used in diapers, feminine products, meat packaging products, wound care materials, wipes, and so on. So we use these fibers a lot, but rayon is probably the most popular for women's clothing because of that excellent drape that it provides. Okay. Now we're going to go back to the slides. And this is kind of a summary of all the properties. So you can see regular rayon is not very strong, and it doesn't have good elastic recovery. It doesn't have good resiliency. It's not stiff. None of these are stiff. They're all hydrophilic. But regular rayon is much weaker than these two other versions, the high wet modulus rayon or lyocell. Okay. All right. So the next regenerated fiber is acetate. And there are two different kinds of acetates. There's acetate and then there's triacetate. These are also regenerated out of cellulose. And what we do here is, if you guys remember, in cellulose, there were those OH groups, the hydroxyl groups. We are acetylating those hydroxyl groups. So we are replacing them with acetyl groups. And this is how we create acetate and triacetate. So the difference between acetate and triacetate is the amount of hydroxyl groups that are acetylated, which means they are replaced with acetyl groups. Acetate was the second manufactured fiber, and it's also the first thermoplastic fiber. So when I say thermoplastic, that means acetate is the kind of fiber that melts when you put heat on it. So when you're ironing acetate, you have to be careful. If you use too much heat, it will melt the fabric. Rayon and lyocell don't have that because they're not thermoplastic. Acetate also gets dissolved in acetone or methylene chloride. So if you're using acetone to remove your nail polish, for example, and you have something acetate and it drips on it, it's definitely going to break the fibers and it's going to dissolve completely if you put it in acetone. So you have to be very careful with that. We produce them by dry spinning. So it's dissolved to create the solution and then it's pushed through the spinneret. Triacetate is not manufactured in the US anymore because EPA banned the production because when they're dry spinning it to dissolve the raw materials and create the solution, they use methylene chloride, and that is a very unhealthy type of chemical, especially for people who are working in the factory will be affected by it, so they banned it altogether. So when you're dyeing it, it becomes a little bit harder to dye these type of fabrics because you don't have a lot of OH groups, especially this primary acetate, triacetate contains no OH groups. So it's very difficult to dye. Sometimes we use solution dyeing, so we add color pigments into the solution before we make the fiber. This is how the acetate fibers look like, kind of like rayon. It has those striations. And this is the chemical structure. So the first one is glucose. This is the base material for cellulose. Okay, so you see the OH groups here. So you are replacing that with an acetyl group here. Okay, so you're actually getting rid of the OH groups, but you still have some in acetate. So it is a little bit different in terms of their properties between acetate and triacetate. So it's harder to absorb water and moisture for these fibers. They're lustrous. They can make really nice taffeta and satin fabrics because of their shine and luster. They can be produced with different amounts of drape or opacity. These are different acetate fabrics. This is a taffeta. This is a Celanese acetate. They wrinkle a lot and it's difficult to remove the wrinkles. So when you're taking care of acetate fabrics, you're not supposed to ringe them either because they will wrinkle really badly and it will be very difficult to remove that. Their dimensional stability is okay. But if you expose them to excess heat, they will shrink and they have a tendency to melt if it is too hot. They are less comfortable in hot weather because their moisture absorption is not good. So they are cellulosic, but they're not as comfortable because they're not so hydrophilic. They have static buildup because of low moisture absorption, low hydrophilicity. They're weak fibers, so we don't use them in areas where we need a lot of like strength, right? They have poor resistance to abrasion. They have average resistance to light. And the drape is not bad, so we usually use them as lining materials, and I'm going to show you some examples. They're weak when they're wet, so you have to dry clean them generally, no rinsing. They're resistant to weak acids and alkalis, but they are definitely not resistant to acetone, because acetone will damage them, and you cannot remove any of that damage. It's going to dissolve the fibers. This is an acetate lining inside a skirt. So they are used a lot in linings because they have this lustrous look and they are perfect for linings. But this one is damaged because they had some stains on them, and that damaged the fabric. So they're easily damaged by certain stains. But we use them in linings because they are smooth, they have a slick surface, they have a good drape, so they are great. Now this fabric right here is made out of rayon and acetate. The warp yarns are soluble in acetone, which will tell you that these yarns are actually acetate fibers. And the yarns in the other direction were not dissolved. So they put both of these in acetone, but you can see that acetate dissolved, but rayon just remained. So this is one way of identifying the kind of fibers in a fabric. Again, these are thermoplastic fibers, so they will melt and they will stick to a hot iron. They're heat sensitive. You have to be careful with them. There's also fume fading that will affect them. So combustion fumes and pollution will stain these type of fibers. This is an example of that. This is the original color, and the color turned into this over time because of combustion and pollution. So it does change color and get damaged. This is another example of fume fading on acetate. So the color has changed over time. And these are some of the properties of acetate and triacetate. They are pretty similar in general, but acetate has a lower elastic recovery and resiliency. It wrinkles more. It has very slight moisture absorption, but mostly it's hydrophobic. But triacetate is definitely hydrophobic. They both melt with heat. They both dissolve in acetone. So many of the properties are similar. So rayon and acetate fibers are both cellulosic, but rayon is more cellulosic, more natural, I should say, than acetate. So rayon and lyocell look a whole lot like cotton. And lyocell especially is probably the one fiber that resembles cotton the most. And acetate is soluble in acetone, remember this. They are manufactured in different ways, but they are a little bit different than synthetics because they're not completely synthesized materials. These are some of the uses. Like I said, we use them a lot in linings and also drapery sometimes. Satin fabrics, brocade fabrics, moire fabrics, taffeta, those are made usually out of acetate as well. We use them in bedspreads, quilts, furnishing, or we can also use them for fiber fill or filters and things like that. I'll talk a little bit about bamboo. This is not such a commonly used fiber, but it's made out of the pulp of bamboo plant. It has a soft, silky hand. It's durable, it's breathable, it has good wicking. We use them in sweaters, towels, blankets, t-shirts, socks, wallpaper, curtains, and so on. It's a sustainable type of fabric fiber because of its production, but it's processed as rayon. It's called bamboo rayon. Aslan is the fiber that is regenerated from proteins instead of cellulose. So it can be soybeans or milk. Soy silk is a registered trademark of Aslan Fibers. So if you ever see soy silk with a registered trademark, that's Aslan. That's a regenerated fiber. They are durable. They have good drape. They are soft, good absorbency, good thermal retention. They're renewable, biodegradable, and they kind of look like silk and cashmere, but they're a lot cheaper. Seaweed is another regenerated fiber. Alginate is another one. Let's go to iTextiles and I'll show you a couple different things about acetate. Acetate, you can see the cross section here. You can also produce them in a Y cross section like this. So acetate is used in cigarette filters. And if you look at the cross section of the fibers, this is the cross section. And this is the spineritol that makes that kind of shape. And if you compare acetate fibers to human hair, they're actually, especially the ones that are used for cigarette filters, are about 40 microns. Human hair is generally around 80 microns. So it's much finer than human hair. These are acetate fibers or yarns, and you can see there's a lot of luster. That's why they make really good satin type fabrics that are used in linings. They have a lot of luster. And this is a dress with acetate lining. So this is the lining material. This is the cigarette filter. And if you take out that and look at the filter, this is all acetate fiber. And they put some acetone on it and it started to dissolve. So you can see that. This fabric here, the lining inside that box is made out of acetate. So it has a lot of shine. It does have that luxury look to it. Generally, dry cleaning is used for these. So you have to be careful because, if you rinse it, trying to get the water out of it, it's going to wrinkle it a lot. So it's not recommended. So this is a summary of the properties of all of these fibers: viscose rayon, modal, lyocell, and acetate. Again, modal is another version of rayon. Viscose rayon is another variation. Lyocell is another variation. So they all have excellent drape. The wrinkle and crush resistance is pretty low for viscose rayon and modal. Lyocell is a little bit better. Acetate is average. The dimensional stability is low for viscose rayon. Modal is a little bit higher. Lyocell is a little bit higher. Acetate is average. They all have these rayon-based fibers have low static buildup because they are still made out of cellulose. They're hydrophilic. They still have their hydroxyl groups. But acetate has high static buildup because of the hydrophobic nature of them. The strength is low for viscose rayon and acetate. Modal and lyocell are a little bit better with strength and with abrasion resistance. Strength and abrasion resistance are very much related. So if a fiber has tensile strength, it usually has good abrasion resistance as well. So you can tell these two fibers are a little bit better than rayon and acetate. Okay, so we're going to finish it here. And I'm going to have an assignment for this.